In this video, I'm going to help you with some equations that involve fractions and decimals. One way to solve equations with fractions and decimals is to just solve like normal and isolate the variable. You can also multiply the equation by the least common multiple, LCM, or a multiple of 10 to get rid of the fractions and the decimals, and then solve like normal. Test number 9 in your 100 equations unit is on equations with fractions and decimals. There are 10 questions and therefore 10 points to add to your total of 100. Let's look at a couple of examples involving fractions and decimals. For this problem, I'm just going to solve like normal. And what I mean by that is I want to isolate the variable d. So I'm first of all going to take care of the constant 1.4, actually negative 1.4. So I'm going to add 1.4 to both sides, and I get negative 14.3 plus 1.4. And I get negative 12.9 equals negative 3d. Again, isolating the variable d, I'm going to divide by negative 3, divide by negative 3. And I would count off if you left your answer as negative 12.9 over negative 3, because we don't have decimals in our fractions. So I would expect you to take that a step further. First of all, realizing that a negative divided by a negative is a positive. You don't actually have to put the plus sign, but it is a positive answer. And 12.9 divided by 3, you could do 4.3 if you wanted to take 12.9 divided by 3 like this. You could arrive at 4.3. You could also move the decimal over one place in the numerator and one place in the denominator to get 129 over 30. However, you would look at this fraction and think, I don't need to reduce that. But in fact, both of those are divisible by 3. 3 into 129 is 43, and 3 into 30 is 10. Again, giving you that 4.3 answer. So just make sure that when you are putting your final answer down that you ask yourself if it can be reduced or simplified in any way. I'm going to do this same problem using the strategy of multiplying by 10. When I multiply by 10, I get negative 143 equals negative 14 minus 30d. And when I add 14 to both sides, I get negative 129 is equal to negative 30d. And this should look very familiar from the previous way I solved it, because when we divide by negative 30, divide by negative 30, negative divided by a negative is a positive, and 129 thirtieths is equal to d. But I would expect you to reduce that, since 129 and 30 both have a common factor of 3. That's 43 over 10. On this next problem, I wanted to include the strategy of multiplying by 10, but also remind you that if you multiply the whole thing by 10 or 100 or whatever multiple of 10, anything in parentheses is protected from that 10. So really the only thing we're going to gain by multiplying by 10 here is 14.2 becomes 142, and the 2 becomes 20. The negative 5.8 plus t is protected. Now we have a distributive property equation where I'm going to distribute the 20 to negative 5.8. And I get negative 116 plus 20t. And when I have this written down, I'm looking now at the t being isolated, so I have a two-step equation here. I'm going to add the constant 116 to both sides to get 258 is equal to 20t. When I divide by 20, I get t is equal to 258 over 20, I know both of those are even numbers, so I can divide by 2. 20 divided by 2 is 10. 258 divided by 2 is 129. You can leave your answer as 129 over 10, or if you wanted to write that as 12.9, that would also be fine. Again, a good way to know if you understand this type of problem is to write it on a separate piece of paper, show all your work and your steps, and see if you arrive at the same answer that I got. For this problem involving fractions, again, there are a couple of ways you can think about it. If you wanted to just do it like normal and isolate the variable n, we would get rid of this constant 1 1/2 by subtracting it from both sides, minus 1 1/2. But in order to take 73/18 minus 1 1/2, I'm going to have to do some changing of one of them to the right format or both of them to the right format, finding a common denominator, and then working from there. And so that's not the wrong way, but when I look at this equation, I see that the denominator 18 is a multiple of all three of my terms here. So 1 1/2 is actually 2 times 1, which is 2, plus 1 is 3. So 3 halves. And when I see those denominators, I know that I can multiply by 18 over 1. And when I do that, 18 over 1 times 73 over 18 cancels out the 18. So I'm just left with 73. When I take 18 over 1 times negative 2/3, I'm going to change my color here, then I have 18 times negative 2, which is negative 36, divided by 3 is negative 12n. You can also say 3 into 3 is 1, 3 into 18 is 6, and then 6 times negative 2n is negative 12n. And then finally, 18 over 1 times 3 over 2 is 54 over 2, which is 27. Another way to look at that is 2 into 2 is 1 time, 2 into 18 is 9 times, and then 9 times 3 is 27. So this looks a lot less intimidating to me than this. So now we have a two-step equation where we want to isolate the variable n. The way we do that is by getting rid of the constant first, in this case minus 27. And when we subtract 27, we get 46 is equal to negative 12n. To isolate the variable n, we're going to divide by negative 12. If you wrote down that n is equal to negative 46/12, I would take off half credit because both of those are even numbers, and I would expect you to reduce that to negative 23 over 6. If you wanted to take it a step further and reduce that to a mixed number, that would be fine, or a decimal, that would be fine, but this is perfectly fine for your answer for this problem. Again, I suggest that you write this problem down on a separate piece of paper, work it out, and see if you can arrive at the same answer that I got. On this last problem for this video, I just want to have you pause for a second and see if you can think of a way to start this problem involving both fractions and decimals. If you thought of converting all of the terms to the same format, then you're thinking along the right lines of my thinking, because I know that 0.6 can be written as 6/10. 6 over 10 is a fraction, or 3 over 5. And I know that 0.7 can be written as 7 over 10. I'm going to actually convert everything to decimals. In this case, I have 0.6x plus 0.75x minus 2 equals 0.5x and then minus 0.7. I also see that I have 2 decimal places here with 0.75x, so if I multiply by 100, I get 60x plus 75x minus 200 equals 50x minus 70. Now I'm left with an equation that has like terms on both sides, so I want to combine the 60x and the 75x here to get 135x. The minus 200 is still there, the 50x is still there, and the negative 70 is still there. Now I have variables on both sides, so I want to pick a side for those. If I subtract 50x from the right side, that gets rid of those. And then when I subtract 50x from the left side, I get 85x. Still minus 200 and still negative 70 on the right side. Now we are down to a two-step equation, and in order to isolate the variable x, I'm going to get rid of the negative 200 constant by adding 200 to both sides. When I take negative 70 plus 200, I get 130, and on this side I get 85x. And when I divide by 85, I would expect you to know that 130 over 85 could be reduced by 5 because they both end in a 0 or 5. So in this case, 5 into 130 is 26, and 5 into 85 is 13, and that is incorrect. It's 5 into 85 is 17, and 26 over 17 cannot be reduced. If you wanted to change it to a mixed number, you could, but 26 over 17 is perfectly acceptable for the answer. So just to review, equations with fractions and decimals can be solved like normal by doing the operations with the decimals and the fractions, but you can also use this strategy of multiplying by the least common multiple when working with fractions, or a multiple of 10 when you're working with decimals. The only thing to remember is that when you're looking at a problem like this one shown, if you multiply by the least common multiple, in this case 18, you want to make sure that anything that was already in parentheses is protected from that. So you would only distribute the 18 to these three terms, and then from there you can isolate the variable. This would be a great problem for you to write down on a separate piece of paper, work it out, and then show me in class, and then I can verify whether or not you got the right answer. So hopefully this video helped you with working with equations that involve fractions and decimals.